I'll be talking about electric charge. At first, what is electric charge? Electric charge is the fundamental intrinsic property. If they say something is intrinsic, what do you understand by intrinsic property? Intrinsic means something uh, that belongs to a particular thing. Let me just say something that belongs to or part of a natural thing. Now, electric charges, they are fundamental intrinsic property to which electric force acts. The action of an electric force actually leads to what we call the electric current. The flow of an electric charge leads to electric current in the application of electric force. Now, fundamental charges is the charges on proton and electron. We have the positive and also the negative charge. The positive charge is known as the proton, and the electron is known as the negatively charged. Now let's look at this, the characteristics of charges. What are the characteristics of charges? The first thing is that charges can either be positive or negative, and we have some charges, let me just say some electrons that are positively charged. They are known as the positron. Now charges is either what, positive or negative. Charges is always quantified in discrete value. What do they mean by quantified? Quantified means that you can express charges numerically. That is, you can calculate the amount of charges that flow along a particular path. Now, charges is always quantified in discrete value, and if they say something is discrete, discrete means something that is independent of other things. Like, let me just say it is independent of other things of the same quantity. That's just it. So the properties of charges are actually, it is either positive or negative. It is always quantified in discrete value, as you can see. And another thing here is that the formula that is used to express the numerical value of charges is given by Q equals to what? Ne, where our Q is what? Q is the charge. Q is the charge. Our N is the number of particle that flow through a particular path, and E is the number of what? Of electron. E is the number of what? Of electron, and number of electron is what? Is said to be constant, which is 1.602 times 10 power minus 19 coulomb. So now look at this. We have our charge here, we have number here, and also what? The mass. As far as proton is concerned, proton has the same number as electron. That is, both of them actually contain the same what? The same number of particles, which is what? Which is 1.602 times 10 to the power minus 19. And that of electron is actually what? 1.602 times 10 to the power minus 19. But the thing is that if you represent our proton by as 1.602 times 10 to the power minus 19, and our electron is also 1.602 times 10 to the power minus 19, we can't know the difference between the two charges. The fact is that we actually need to add minus here to differentiate it from proton, so that we know that our electron is negatively charged while our proton is positively charged. Now, as far as the mass is concerned, the mass of proton is different from the mass of electron. The mass of proton is actually 1.67 times 10 to the power minus 27, and the mass of electron is 9.11 times 10 to the power minus 31. You shouldn't just mistake it. Don't make the mistake. They are actually different. The mass of proton is 1.67 times 10 to the power minus 27, and that of electron is 9.11 times 10 to the power minus 31. Now let's move to the third characteristic or third properties of charges. Here it says charge can neither be created nor destroyed, but can be transferred from one body to another. Actually, the thing is that these properties or characteristics actually holds true for our matter, mass, energy, and as far as charge is concerned. We said charge is an intrinsic property. Intrinsic means something that belongs to parts of natural thing. As far as energy is concerned, energy also belongs to part of natural things now. So that's just the fact behind this. And this law, or let me just say this characteristic, will be the what? The law of conservation of charge. Law of conservation of charge. Law of conservation of charge. So these are the three basic characteristics of charges that we have. Some other characteristics or properties that we have is that like charges attract, like charges repel, while unlike charges attract. For example, in the sense of positive and also negative, and positive and also positive, negative to negative. These are what are like charges. They are going to repel each other. That is, the force that is going to be dictated or experienced between these two charges is going to be a repulsive force. But as far as this and this is concerned, they attract each other. The force that will be felt, that will experience between these two charges, will actually be what an attractive force. An attractive force. And likewise, this is going to be a repulsive force. So this is just an additional properties of a charge, but it is well explained in the let me just say, when we are talking about electric field, that's when we'll be talking about these properties very well, because as far as electric field is concerned, it just tells us the kind of force that is experienced between two charges, and it just elaborates more on the magnitude of force, the magnitude of the charges, and the distance that is experienced between the two charges, or the force that is acting between the two charges. Now, and what is field? If you are talking about field is just a region of space where the influence of an electric force is experienced. And don't forget that what brings about current is actually the flow of electric charge. And the flow of electric charge occurs between two charged body. Let's say you have a charged body Q1 and also a charged body Q1 and a charged body Q2. This and this, they will actually experience an electric force between the two. The type of electric force that they will experience depend on their nature. If this is positive and this is negative, they are going to experience an attractive force. That is, they will move inward with each other. But if this is positive and this is also positive, they will experience confirmed repulsive force. That is, this will move away from this. Q2 will move away from Q1 and Q1 will move away from Q2. Now let's check some question I'm having here for you guys. Looking at this just small and cheap question here. The question is, the next charge on a body carrying 20 proton is, we are asked to calculate the next charge on a body carrying 20 proton. Using the word, we said according to the price of charge, we said charge can be quantified using Q equals Ne, right? And I gave you guys that our E is number of electron, which is taken to be minus 1.602 times 10 per watt. That's minus 19, right? And here the question says the next charge on a body carrying 20 proton. That means we are asked to calculate for Q carrying 20 proton. That means 20 protons means the number of particles. And don't forget that particles are the proton, electron, ions, and also molecules as well. So here if we are talking about number of electron, that's number of proton that are involved is that's 20 proton. She gets right now. So in this case, let's just go. And since the question is talking about proton, there is no need of putting negative here. It will be positive charge. Now let's go. Here we are having Q equals Ne. Let's go. We ask calculate for Q. Then we have Q to be equals N is that's actually 20 multiplied by 1.602 times 10 to the power minus 19. Then I can just write this as 20. Let me just say 2.0 times 10 raised to the power 1 abi times 1.602 times 10 to the power 10 raised to the power minus 19, right? Then here I can use this to multiply this, show that I will have Q to be equals that's 3.204, right? Yeah, I use these two to multiply this. Multiply 10 raised to the power 1 times 10 raised to the power minus 19. Then use indices. You are going to have Q to be equals 3.204 times 10 raised to the power, that's minus 18 coulomb. So this is our answer. D is our answer. Now let's move to question 2. Question 2 says the number of electrons contained in 1 coulomb of charge is the number of electrons. We are asked to calculate the number of electrons in this case, N, right? Contained in 1 coulomb. We are giving our 1 coulomb, that's our charge. 1 coulomb of charge is, now in this case, what do we need to calculate for? We are asked to calculate for the number of electrons. Then given that the electron, constant value of electron is 1.602 times 10 per minus 19, right? Then just go and do Q equals that's Ne, right? You recall the formula, your Q is 1 equals to that's 1.602, right? Times 10 per minus 19 N. Then divide both by 1.602 times 10 per minus 19. Dividing both by 1.602 times 10 per minus 19. This we cancel this out, right? So what do we have here? We are going to have our N to be equals to 1 over 1.602, right? Then times again 1 over 10 raised to the minus 19. Can you see this now? So 1 over 1.602 times 1 over what 10 raised by what minus 19. Here I'm carrying this to this side. I'm going to have my n to be equal to what? That's 1 over 1.602. So you give me something like that's here I'm having 1 over 10 raised by what minus 19. I should be having something like 6.2 times 10 raised by what that's 18 column, because by the time I bring this to this side I'm going to have 10 raised by what that's 19, and 1 over 1.602 is actually will give me something like 0.62 something. So that's how by the time you solve it you have 6.2 times 10 raised by what 18 column. Now the answer should be what C. Now let's move to the third question. The third question here says the number of elementary particles that gives a body net charge of Q equals to 8.01 times 10 per minus 17 column is. Now here we ask actually the net charge of a body, the number of the number of elementary particles rather. So now in this case let's just go by saying we don't know the value of what of our number, the number of elementary particles that gives a body a net charge. The charge is what Q, which is equals to that's 8.01 times 10 raised power minus 17, right? Yeah, 17 column is. So we are now calculate the number, then the number of particle. What kind of particle are they talking about? I don't think they specify. Maybe it is proton or electron, but you can just go ahead and just choose our number. Our E to be equal to 1.602 times 10 raised power, that's minus 19 column, right? So now let's go ahead and solve it. No, Q equals to what NE, right? So our N will be equals to what that's Q over E. Go ahead and substitute the value here. I'm going to have n to be equal to what that's 8.01 times 10 raised to power minus what 17 column divided by what our E to be equal to 1.602 times 10 raised to power minus what 19 column. Then here I can actually what separate. I'm going to have my n to be equal to what 8.01 divided by what 1.602, right? Then multiply what 10 raised to power minus 17 divided by 10 raised to power minus what 19. Very good. Then my n equals what 8.01 divided by what 1.602, then multiply what 10 raised to power 7 minus 17, right? That's plus 19 rather. So you're going to have n to be equals what 8.01 divided by what 1.602, right? Then multiply by this should give me 10 raised to power that's 2. So look at this. How can I solve this kind of question? I'm having 8.01 divided by 1.602. It's very simple. It's just like I'm having n to be equals to, if I approximate this is actually what 2 divided by 4 is what is that's should give me that's 4. 2 divided by 8 divided by 2 is what is 4, right? I'm having 4 here, but with this I should be having something like 4.5 something, 4 point, let me just 5 blah blah blah. Everything if I approximate, I'm going to have times 6 by what 2. 8.01 divided by 1.6, it should give us something like about 5. Yeah, rather it should give us something like about 5. So I'm having n to be equal to 5 times 10 is by what 2, which is equal to what 500. So here I'm picking my what my 500. That's how this is how you can calculate. You can solve some question without using calculator. You understand it down? Just know the techniques and try to what. Can you see I separated them here, then try to simplify, and 8 divided by 2 will give you 4. But I'm having 8.01 divided by 1.602. That means it's not up to 2. This is not up to 2, and this is not up to what? Up to 9. Then by the time you divide it, you should be having something like what? Like 5. So the answer is 500, and that's it. That's it. So if this is your first time watching my video, don't forget to click on the subscription button and feel free to drop your comment, your question in the comment box below. And if you want me to solve any question for you, you can actually drop the topic and also the question you want me to solve in the comment box below. I'll be there to reply your message. Thanks for watching.